and welcome back to the Polymath Teacher! Expectations are the same as they've always been, so use twice this video's length and stay attuned to make sure that you can pause, take notes, and you're actually working through this. When I say pause, you're actually pausing and trying it, and then making sure you're checking as you're going. Alright? Alright, so unit objectives, we've already named, we've added, we've subtracted, we've multiplied a bunch. Now we're on graphing quadratic functions, alright? So graphing quadratic functions, let's go do it. Let's go do it. You've graphed lines, so now we are going to go graph quadratics. If you want a refresher on how to graph in general, make sure you're going back to our relations and functions unit, so go to plotting points, and then also go to functions, but then also interpreting functions. What number was that? 23, 24, 25. 24 is really nice because it has a table. Okay, so this kind of table is what we're going to work with for graphing, but then we're going to do quadratics. So just an FYI that it is going to be squared. Yeah, squared. I guess I should probably do a little random aside thing that if I have 3 squared, that's how you would say that, is 3 squared, or 3 to the second power. This means 3 multiplied by 3. We've done that, you know this, great, woohoo, it's 9. Now, if I said the square root of 9, that is asking what multiplied by what makes 9. And we can get into some arguments here. So technically, the square root could be a positive 3, because positive 3 multiplied by positive 3 makes positive 9, or it could be a negative 3, because negative 3 multiplied by negative 3 also makes a positive 9. So for the sense of functions, we only care about the positive, but it does come into play later in this unit that there is a negative option. So that's a random aside of what square root actually means versus a square. We're not really going to see that in this lesson, but I wanted to make sure that you were aware that square and square root are related to each other because they are inverses. They undo each other. All right, so let's do pink, because why not? So I want to remember standard form for quadratics. So I've talked about standard form for polynomials, but if we already know the degree, then standard form for a quadratic is going to be ax squared plus bx plus c. All right, so we know it's going to have a degree of 2. That highest degree is going to be 2. It's going to go with the quadratic, a linear, then a constant term. And then we pronounce f of x as function, that's a 0, that's an O, of x, okay? So just an FYI refresher, you've seen it before for linear, but now we're going to see it again for quadratics because we're graphing it. Woohoo! Okay, so we are going to have steps, and then as we work through the steps, we are going to see them in action in our example. So our goal is to graph one whole quadratic by the end of this paper. So the problem that they are going to give us is to graph the parent function f of x equals x squared. This is called a parent function because it is the most basic quadratic there is, okay? We're dropping off the bx, we're dropping off that linear term, we're dropping off a constant. It's literally just 1 times x squared. So it's just x times x, all right? So now we're going to put into standard form, all right? Now, I am going to also mention that standard form goes in 2 different things, okay? Well, I guess it doesn't actually matter. I'm not going to do that. Nope, we'll just say equals f of x. Sometimes this f of x is going to turn into a 0. So just an FYI, we are going to do that later, but I'll explain why later versus doing it now. Okay, so I'm going to have f of x equals x squared plus 0x plus 0. So notice that because it was so basic, x squared is going to come down, but I still have to show that bx and c exist. So I'm going to put zeros there because they're just invisible zeros. So I'm going to make them 0 so we can see the invisible b and c. All right, so this means that a is going to equal 1 because that's the coefficient of x squared. B is going to equal 0 because that's the coefficient of x. And c, my constant that has no variable, is going to be 0. So even if this wasn't in standard form and it was all rearranged, a would still be 1 because it's the number in front of x squared. B is still 0 because it's the coefficient or the number in front of x. C is still 0 because that's the constant that has no variable, okay? Even if this was rearranged to be c plus ax squared plus bx, it doesn't matter. A, b, and c will still be these values, all right? So in order to graph, our next step, I guess, you have a problem, put it in standard form so you can find the a, b, and c. That's our goal, is to find a, b, and c. Implies, okay. And then we're going to find the axis of symmetry. So I drew earlier in the air a couple lessons ago that parabolas are symmetric. It's a U shape, and the letter U is symmetrical. So a parabola, I am going to define it later in this lesson as well, but parabola is a U shape. That's our quadratic. That's the general shape we're going to be graphing. So it is symmetrical. There's an axis of symmetry down the middle of it, all right? That axis of symmetry happens to always follow this pattern. It's always a vertical line. Remember, x equals a number is a vertical line, and it follows a vertical line such that the opposite of b is divided by 2a. That's your perfect number, all right? So if I want x equals negative b over 2a, well, I know b is 0, 2a, a is 1, and this simplifies to 0. So my axis of symmetry is at x equals 0. All right, so this implies my axis of symmetry, I could fold the parabola in half at x equals 0. So before I move on to, like I said, this is the next step. Never mind. This is the next step. We're going to make a table and a graph. So my table is going to be x, y, boom. You could replace the y with f of x, and if you want to add that middle column for work like we did on page 24, then you're welcome to do that as well. And then I have my graph. All right. So I'm going to be using my pen now just so we have a contrast of colors. And so my axis of symmetry is that x equals 0. That means that at x equals 0, that is my axis of symmetry. I'm going to put that there visually with that dashed line. I now know the left side is going to be a smack dab image reflection of the right hand side because it's the axis of symmetry. So I'm going to start with my axis of symmetry because I want to start from the middle and work out. So this is my axis of symmetry. All right. So I'm going to have that 0, and now when I substitute in that 0, I'm going to get 0 squared. 0 times 0 is 0. So the coordinate that is my vertex is going to be at 0, 0. All right, and we are going to label that in a sec, but I want to finish the table and finish the graph first before we label things with new vocab. All right, from here, it's nice. I'm going to make a good scale. Okay, so from the axis, it's nice to go out 1. So you can either go to positive 1 or to negative 1. So if I went to positive 1, f of 1 equals 1 squared. 1 times 1 is 1. So my coordinate is 1, 1. All right. To show this, you don't write this unless you wanted to, but to show this for a negative, I am going to change this. What if it was a negative 1? If I put a negative 1 in for x, I'm going to end up with negative 1 squared, but negative 1 multiplied by negative 1 is still positive 1, so this is my new coordinate. So you will get a negative 1, 1 and a 1, 1 from doing the math one time. You get that extra bonus point for doing math one time, you get 2. It's a nice 2 for 1. Really nice. Parabolas are awesome. Okay, once we've gone out from the center, from the vertex, we're going out 1. I'm going to go out 1 more, and let's go to 2, because that's a nice positive number. 2 multiplied by 2 is 4. That means my coordinate is 2, 4. And my bonus coordinate will be negative 2, 4. Because think about it, if I plug in a negative 2, I'm going to get negative 2 multiplied by negative 2, and that's a positive 4. So I'm going to go 2, up 4, negative 2, up 4. And then this is a continuous graph, continuous function, so you can connect the points. And from 3 coordinates, I did math only for 3 points, but I found 5 points. So you need 5 to make a good graph, an actual, like, accurate, predictable graph, but you only need to do work for 3 of them. So, woohoo! So nice. All right, and then this 0, 0 is considered my minimum. Sometimes you have a parabola that is an upside down U, and that would be then your maximum. And this would be your vertex as well. All right, so I am going to label some or define some things over here. So parabola is going to be our U-shaped curve. So I want you to pause the video and say parabola 3 times. Parabola, parabola, parabola! I hope that shocked you. That was the goal. Okay, vertex. I'm home alone, so I can yell as much as I want. Parabola! Yeah, I hope that made you smile, or at least get annoyed, then you're at least like in it, because if you're annoyed enough, that means you're paying attention. Okay, vertex. So vertex is going to be the tip of your parabola, and this will always be your max or your min. All right, so if you have an extreme point, an extrema, then in this case we have a minimum, but if it was upside down, it would be a maximum. So there's only one max in this case, and there's only one min in this case. So, woohoo! We could after it! We could after it! So, making sure that you find your A, B, and C, then you find your axis of symmetry, and the axis of symmetry is nice because it gives you the starting point for your table. If we had started at -5, we would never have gotten the freebie points to begin with, but we would have only gotten part of the U shape, and we would never have seen the rest of the shape. So starting in the middle at your axis of symmetry is going to help give you the best shape, the quickest on your graph. All right. Trying to keep these under 15 minutes. We're just over 12. Here are your comprehension questions. Why are x-intercepts such a big deal? Look back at our example that you just graphed. What is the x-intercept? That x-intercept is actually called a 0 or a root. It's the location that's on there. It's grounding us to the x-axis. So why would we call that so many different words, x-intercept, root, and 0, and why would we care about it this much? So think about that going into our next video. Thank you, and have a great day. Bye.